Okay, now we're going to do 2 expected value examples in this video, and then in the next video we will do another 2 examples. Right now I am on page 14, and I'm going to do examples 1 and 2. Hopefully you can see where I just wrote page 14. Okay, so this is the first one. I'm going to grab this highlighter. It says a carnival game offers a $100 cash prize for anyone who can break a balloon by throwing a dart at it. It costs $5 to play. You estimate you have a 10% chance of hitting the balloon on any given throw. Find your expected winnings. So in this case, I either break the dart or I don't, which means I hit the balloon or I don't hit the balloon. And if you look at the way this is written, it says I offer a $100 cash prize for anyone who can break the balloon. So I either, in this case, have a winning outcome or I have a losing outcome. All right? So if I talk about how much money, right, in terms of the X variable here, in this case, this is my quote unquote, winnings, okay? So we want to keep in mind in this case that I actually paid to play this game. So I actually think it might be easier if we discuss the probability first, because it says here I have a 10% chance of hitting the balloon. And it also says that I win when I hit the balloon. So that means that I want to convert 10% into a probability, or write it as 0.10 or 0.1. And if you remember in our rules, it said to make a valid probability model, these numbers have to sum to 1. So in order to find the missing value here, we could subtract 0.1 from 1. So in order to find this number, we could do 1 minus 0.1 and we get 0.9, which means in this case I win with a probability of 0.1, but I lose with a probability of 0.9. And because this app is so sensitive on where I put my Apple Pencil, I am not going to go back and fix that 9 there. So next, we want to fill in the value that we actually win for each one of these games. This one says I get a $100 cash prize for anyone who can break a balloon, and it costs $5 to play. So I want us to think about when I win, I'm going to make $100, but I'm actually going to lose $5 every time I play the game, which leaves me with exactly $95 that I would make when I win. So this gives me $95. But if I lose the game, I actually just lost or made my bank account negative by $5. So in order to find the expected value, if you guys remember from the notes, we take each of the values and we multiply x times p of x and then add them together. So I'm going to go ahead and write that next to this. It says find your expected winnings, which means what to expect. In other words, my expected value. So for my first pair, I would take the x is the $95, and I'd multiply that by the probability that I would win, which is 0.1, and then I'm going to add to that. So here we multiply again, negative 5 times 0.9. And that's how we would do this by hand, if you wanted to think about how you do this by hand. And if you go ahead and plug that into your calculator, exactly as I wrote it, like with parentheses and then the plus sign between all those sets, then you would actually realize that you here get $5. So I want to show you the first time by hand, and then from now on we can check this in our calculator. So to check in the calculator, we would put x in L1 and p of x in L2. So I can give you a second, or you can pause this video and you can go ahead and do that. And then remember, what we would do once we enter that information is we would go to one var stats, which in the notes video, I remind you of the steps to get there in the calculator. And then you want to remember that you actually have to tell the calculator that these one var stats are actually on two variables. Technically, L1 is the variable, right? And then the second one is our probability, right? Our frequency, if you have a fancier calculator. And in this case, right now we've got L1 and L2, and you would see if you hit enter after this, X bar, wow, that sucked. X bar, wow, guys, I'm trying to write without touching the screen with my hand. It's really hard. X bar equals 5, which is the same as what we got as our mean. This is also the first example we're doing, so if you are doing this in the calculator and following me along, then you would also see that X bar is, sigma X is there, but SX is not there. And if we wanted to find the standard deviation, then we would actually be using the value for sigma. Okay, so let's do this one more time on this page. Then I'm going to ask you to take a break from the videos and try example 3 on the same page on your own, which in fact, if you kind of scan ahead in your packet, example 3 would just be practice in the calculator. So I'm going to hope that we actually do this next example in the calculator, and then we go ahead and practice example 3 as well before jumping to the next video, which will include example 4, and then expected value will be done. All right, so let's read this one so we can set up our little table. This one says, in a game, a player can bet on red and have a 0.4 probability of winning. If red turns up, the player wins $25. Otherwise, the player loses. Find the probability distribution and the expected gain or loss. How much would you pay to play this game? So this is a new question that we're being asked, and it's a little bit of a weird one, but I think it might pop up in the online homework, which is why I threw it into the packet. So I see one difference here, and it's that I do not have a pay to play. So in this case, I have nothing to subtract. When I lose, I'm not really losing from my bank account in this problem because they have not told me what's going on. In fact, they actually asked me, how much would you pay to play this game? So it's our job to figure out what the pay to play is, which means that the outcome or the winnings, right, in this case, will actually be a little bit easier for us to determine. There's no subtraction because there's no pay to play rate given, or the cost it is to bet, or the cost it is to play, however it's phrased. I don't have anything that I need to put in the losing value besides $0. Then I want to go back up. It says a player can bet on red and they have a 0.4 probability of winning. So winning is the same as getting red, and losing is the same as not getting red. So if we're thinking about probabilities, then we would say that here winning is the 0.4 chance, and here we would do the same subtraction method we did above, which, just to remember, was 1 minus 0.4 to get 0.6. Reminding you that the P of X column has to sum to 1 in order for this to be a valid probability distribution. So first it says I find the probability distribution. We did that. And the expected gain or loss. So that's my expected value. So here I'm going to ask you to go to your calculator, enter the X values, or 25 and 0, into list 1, enter P of X, or 0.4 and 0.6, into list 2, and then please run through the steps that I listed above to calculate your 1 var stats using list 1 as your X list and list 2 as your frequency. And if you have an older calculator, type exactly what I wrote above. I'm just about to put a box over it. Old calculator people, it should actually look exactly like what's in that little box up here with L1, L2. And then once you go through the motions, you end up with, I'm going to stick the units on here, $10 as your expected value. So the statement I always like to make is, now that we've found our expected value, we can actually answer the following question. All right? It's it's phrased similarly to kind of wanting to break even in terms of how much you would say to pay to play this game. It's not like, I'm not asking your opinion. I don't really care what your opinion is about playing this game. I'm really asking based on the expected value, right? How much would you pay to play this game? And I always use the expected value in my answer. So I would say like, let's spell it right. Since the expected value is $10, you would not want to pay more than 10 to play this game. And the way I phrase it is to make sure E of X would always be positive. So since the expected value is $10, you wouldn't want to pay more than $10 to make sure we would always have a positive expected value. Remember, this is telling me, in essence, if I play this game over and over again, right, I expect to come out on top by $10 if I play several times, all right? It's not saying like I could ever win $10. I know that's not a situation. I either win $25 or I lose my money. And in this case, I don't lose anything. They're just saying over time, with this probability, I would expect to get $10. So we'd say over time, we wouldn't want to be spending our money that excessively, right? So we would want to say that we wouldn't want to spend more than $10 each round. That's what this kind of question is asking, in case that comes up in the online homework. Now, for example 3, I'm asking how many red lights would she expect to hit each day? So what I want you to do is calculate the expected value from the table that's given in example 3 using only your calculator and check it with my solutions that are online. And catch me again in the next video for example 4.